Hello, I'm Dusty Bottoms.
And I'm Hannah Histidine.
And welcome to the Daily Enzyme. Today we're talking enzymes. Do you know what's so exciting about enzymes? Lipase. Today we have a special interview. Frank Enzyme, our man, is going to interview Dr. Cole.
Thank you, Hannah. Joining me today is lipase expert Dr. Cole from Christopher Newport University, who is speaking with us today about the importance and function of lipase. Dr. Cole, thank you for joining me today.
Mm-hmm.
So, Dr. Cole, many of our viewers are wondering, what exactly is lipase?
Okay, lipase is an enzyme that hydrolyzes lipids, specifically the ester bonds and triglycerides. Within the human body, lipase can be found in the pancreas, the mouth, the stomach, all which makes sense because we know that lipase breaks down lipids, so they should be found in areas of the digestive system where things like fats are being broken down to be absorbed by our bodies.
So basically what you're saying is that lipase is in charge of breaking down fats in our bodies. So tell me, why exactly is that so important?
Okay, so nutrients for the cells in our body are transported via the bloodstream, which is water soluble. Fats aren't, so they can't be easily transported through the bloodstream alone. So they become an unusable energy source. Lipase is there to break down, in this case, fats, and facilitate their transport.
That's incredible. Who knew a single enzyme could have such an impact on our lives? So Dr. Cole, is there anything you can tell me about the, structure of lipase?
We will. Okay, the structure is really quite interesting. All of its components don't just come together willy-nilly. Everything has its specific place and purpose. There's a variety of lipase enzymes, each ranging in size, substrate specificity, and positional specificity. So they're pretty complex. But one thing that is worth remembering for all lipase enzymes is the distinct distribution of the hydrophobic and hydrophilic residues, which kind of goes along with the structure dictates function.
Well, there you have it. The importance of lipase cannot go overstated. I'm Frank Enzyme, reporting to you live for the Daily Enzyme. Hannah, back to you.
Wow, that was fascinating. Next, we're going to talk about the structure of lipase and what really makes it genuinely special.
A diverse array of lipase enzymes appear in the human body. Right now, we're going to zoom into the pancreas where lipase is produced to have a closer look at the structure of lipase. Most lipases are built upon an alpha-beta hydrolase fold and possess a chymotrypsin-like catalytic triad comprised of an acetic residue, a histidine, and a serine nucleophile. Structurally, lipase is a single-chain glycoprotein of 449 amino acids. The secondary structure is composed of 13 alpha helices and beta sheets that compose 28 strands. Within each chain, there is an N-terminal and C-terminal. The N-terminal contains an alpha-beta hydrolase fold. The C-terminal has a beta barrel that relates to colipase. Colipase allows lipase to adhere to the micelle at the lipid-water interface. This bonding prevents lipase from being washed out and prevents the inhibition of lipase. Each structure of lipase, monomer, and dimer are bonded using intermolecular interactions, such as disulfide bonds, hydrogen bonds, and electrostatic interactions. Within lipase, there is a positively charged nitrogen that interacts with the negatively charged oxygen, forming the electrostatic interaction. Further, the side chain and main chain of lipase are stabilized via hydrogen bonds. Other intermolecular forces that dictate lipase's structure are its hydrophobic and hydrophilic residues. The hydrophobic residues create a hydrophobic core that contributes to the formation of the secondary and tertiary structure.
Wow, that was really exciting. Now we're going to check out the mechanism of the lipase. Aren't you excited?
Okay, we'll have the catalytic triad right here, consisting of the aspartic acid 176, the histidine 263, and serine 152. What starts the process is the histidine activates the serine by pulling off this H right here, which makes the oxygen of the serine attack the carbonyl group right here on the substrate, which makes these electrons go on the oxygen right here, which then forms this product I'm about to draw. So what happens then is the ester bond right here will break by pulling off the H from the histidine. These electrons will go back on here. That's how you get the first product release, basically, after this step right here. And these electrons will ultimately go back on here from the double bond. Okay. So as previously stated, this reaction creates a product right here, which afterwards there's an H2O molecule which comes in and is activated by this histidine residue right here. It attacks this hydrogen, and then the hydroxyl group, and then attacks the serine 152 carbonyl group, forming another intermediate. So right here we have the reformation of the double bond, which lets this serine come off and grab a hold of that hydrogen. Those electrons right here go back on the nitrogen, and this reforms the catalytic triad and the active site and releases the second product. So the previous reaction leads to the formation of the second product and to the reformation of the catalytic triad, which I'm about to draw.
That was truly done well. Next, we have a few user-submitted videos. This one coming up is from Forrest. Forrest, show us what you got.
Mom, I'll be there in a second. I'm doing that user submitted video for the daily enzyme, okay? Gosh. What's up, viewers? Lipase Dizzle here to rap to you about digestion and lipase. Y'all like Fresh Prince? Because it's my favorite show. And you know that theme song, man? I sing it all day long. All day long. To start hearing that beat in your head, I'm going to rap to you about lipase. In the digestive system, lipase rules and reigns. In the pancreas, it spends most of its days chilling in bile pancreatic juices. It digests fat in popular places. Some triglycerides I ate were up to no good. Started being difficult to break down. I couldn't do it, so I called on lipase. It broke the ester bonds and started digestion. But for some who call on lipase to digest, it won't come near. Their body doesn't produce enough, so diarrhea you fear. Nutrient absorption will be rare. So hey, don't you forget it. Lipase, you need it. Boom.
Well, that was different. Well, that's all we got for you today. Have a good one.